In today's life, we want to look at examples of sequences and series. Our last video, we started sequences and series, and I explained the difference between sequences and series, and I also give us what is it called? I give us the formula to use. I give us the formula to use for both sequences and series. All right, so now I have a question here. The question says, find the sum of the first 25 terms of the arithmetic progression 7, 10, 13. Okay, so now the formula for the sum that I gave us in our previous live class is n over 2, open bracket 2a plus n minus 1, then d. This is the formula we use to find the sum of AP, the sum of AP. All right, so let's write out our parameters. Let's write out what we have, all right, so that we can calculate the sum. Our first term is A. From this sequence, what's our first term? It's 7. Then we need our common difference. You know, the common difference, that's difference between the second and the first, the third and the second. All right, so when you check what's the difference between 10 and 7 is 3. All right, so, and then what else do we need? We need our n. Our n is the unknown term. All right, so, and then if you check the question, we have to find 20, the sum of the first 25 terms. So it means our n is 25. Okay, so our n is 25. Then we have everything we need to do what? To find the sum of the first 25 terms. Now let's start. The sum of the first 25 terms equals to our n is 25. So we have 25 over 2. Then 2 times our a is 7. Then plus our n is 25 minus 1. And our common difference is 3. Write 3 here. All right, so now we have 25 over 2. 2 times 7 is 14 plus 25 minus 1 is 24. So we have 24 multiplied by these 3. All right, so we have 25 over 2. Then we have 14 plus 24 times 3 will give us 72. So we have this to be 72. All right, so now by the time we add this together, we have 25 over 2. Then we add this and this together, it gives us 86. We have this to be 86. All right, so from there, 2 can go in 86. So we can say 2 here 1, 2 in 86 is what? Is 43. And then we have 25 times 43. So we have 25 times 43. 25 times 43 will give us about, okay, will give us 1,075. All right, so it means that the sum of the first 25 terms is 1,075. This is the answer. Yeah, I hope you guys can see it. All right, so the sum of the first 25 terms is 1,075. All right, so now let's look at another question. Let's look at another question, still on sequence. Okay, series and sequence. All right, so let's look at another one. Another question, example 2. Okay, so this one says the fifth term of an AP is 17 and the 10th term is 32. Okay, so you have to find the first term, find the first term and the common difference. Find the first term and the common difference. Okay, so that is what we have. All right, so now we have the fifth term of an AP to be 17, and we have the 10th term to be 32. So it means we have two equations and we're going to solve it simultaneously. But don't forget that for AP, if you want to find the n term of an AP, this is the formula that we use. We use Cn equals to A plus n minus 1 close bracket D. That is what we use to find the nth term of an AP. All right, so we have two different terms here. We have the fifth term, which is given to be 17. We also have the 10th term, which is 32. So we're going to do that separately. Let's start with the fifth term. For the fifth term, it means our T5 is given to be 17. And that means that in this case, what is our n? Our n is what? Our n is 5. That is the first case. So now let's use this formula to generate the first equation. Right, so our T5 equals to A plus, then what is our n? Our n is 5 minus 1. The difference we don't know. All right, so the T5 is given to be what? To be 17. So under this T5, we're going to write 17. 17 equals to A plus 5 minus 1 is 4. That will be 4D. So we can name this the first equation, equation 1. All right, so for the other sentence, we say the 10th term is 32. We say that the 10th term is 32. All right, so that means that our T10 is 32. And in that case, what is our n? Our n will be 10. So we are going to use the same formula. This is the first case. Then the second one, we're going to use the same formula. Our T10 equals to A plus, what is our n? Our n here is 10 minus 1. We don't know our common difference. The T10, the 10th term, and this is equation 2. All right, so now we're going to solve this simultaneously. We're going to solve this equation simultaneously. All right, so we have equation 1, which is A plus 4D equals to 17. And we have equation 2, A plus 9D equals to 32, equation 2. All right, so how do we solve it? We can do substitution, or let's do elimination. Let's eliminate A. All right, so now it means we eliminate A by what? By subtraction. A minus A will give us 0. And then we have 4 minus 9 will give us minus 5. So we have minus 5. Here, 17 minus 32 will give us minus 15. Right, so we're going to have minus 15. So from here we can divide. So our D now will be minus 15 divided by minus 5. So obviously our D is what? Our D is 3. So our D equals to 3. We need to find our what? Because the question says you find the common difference and the first term. All right, so we are going to find our what? Our A now. Okay, let's find our A. Come in. All right, so let's find our A. Now I'm going to clean this. Our D is 3. So we can use either equation 1 or equation 2 to find our A. We can use equation 1 or equation 2 to find our A. So let's write one of the two equations. Let's go for equation 1. Equation 1 says that A plus 4D equals to 17, and our D is 3. Since anywhere we see D, we write 3. So we have A plus 4, our D is 3, equals to 17. And then that says that 4 times 3 is 12. Okay, so we take 12 to the other side. Okay, so we say our A now equals to 17 minus 12. That means our A is 5. All right, so A is 5, and what is our D? Our D is 3. This is the final answer. All right, so that's how to calculate our A and our D. Okay, so it means anytime you have two sentences like this, what you're going to do is you have to solve them simultaneously. Just follow the steps. You look at the first sentence, you write it, then the second sentence, then go to solve them simultaneously. So let's look at another question. Let's look at another question. Example 3. Example 3. Example 3. Okay, so now let's look at GP. The one we've been doing, we treated 2 questions on AP. Let's also look at GP. Let's look at another question on GP. All right, so this one says find the 8th term. Find the 8th term of a GP whose first term is 2 and the common ratio. And the common ratio is 3. Okay, so from here, we have to find the 8th term of this GP. All right, and then we are given the first term to be 2 and the common ratio to be 3. All right, and I hope you still remember the formula we used to calculate the n term of a GP. The n term of a GP, okay? So now if you are finding the n term of a GP, we have AR raised to power n minus 1. All right, and then write out the parameters, what we have. I've already underlined what we have. All right, so our A, which is the first term, our A is giving us 2. Our common ratio, which is R, is giving us 3. And our N, what is our N? The question says 8th term. It means our N is what? Our N is 8. So let's just insert, substitute for those values there. Okay, so our T8, okay, all right, sorry for that. Our T8 equals to 2 times 3 raised to power 7. You know, I did 8 minus 1, which gives 7. All right, so now this power 7 is for 3. All right, and what it means is that we have 3 in 7 places. 3 in 7 places, and that is 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7. So that's what it means. So 3 times 3, 9, 27, 81, 2, 4, 3, 24, 3 times 3. This is 9, 12 remainder 1, 6, 7, 7 to 9 times 3. 7 to 9 times 3 is going to give us about 2,187. Okay, so 3 raised to power 7 will give us 2,187. All right, so we multiply that by 2. So now when you multiply that by 2, we have about 4,374. So it means that the eighth term of this geometric sequence, the eighth term is 4,374. That is the fourth term of that GP. All right, so now let's look at another question. Let's look at another question. That is example 4. Let's look at another one. Example 4, still on GP. All right, this one says that the third term of a GP, example 4, the third term of a GP is 24, and the sixth term is 192. Okay, so you have to find the common ratio. Find common ratio. So you have to find the common ratio. All right, so now this is still GP. Don't forget, if you are looking for GP, the n term of a GP, we are going to use this formula Tn equals to AR n minus 1. But just like the other question on AP, we have two sentences here. The first one talks about the third term of a GP, which is 24. That will generate equation 1. And the second sentence here talks about the sixth term of a GP, which is 192. So 192. So we have two equations, and we're going to solve it simultaneously. Now, the first one, the third term is 24. That means our n is 3. That's the first one. So we're going to use this formula now. The third term now equals to our a, we don't know. Our r, our n is what? 3. So we have 3 minus 1. The third term is given to be 24. So our T3 now, we're going to write 24. So 24 equals to AR. 3 minus 1 will give us 2. All right, so we can say this is equation 1. And then the other sentence, the sixth term is 192. So that means that our T6 is 192. And that makes the n to be what? To be 6. So using the formula again, which is our T6 equals to AR. What is our n? Our n is 6 minus 1. Okay, from the formula. Remember, this is the formula. This is the formula. All right, our T6 now, the system is 192. So we have 192 equals to AR. 6 minus 1 is 5. We call this one equation 2. So we solve this simultaneously. Equation 1, equation 2. And then how do you do this? Because it's geometric. In geometric, I told you we deal with multiplication and division. In geometry, we deal with multiplication and division. So we are going to divide equation 2 by equation 1. All right, so what is equation 2? Equation 2 is AR raised to power 5 equals to 192. This is equation 2. We are going to divide it by what? By equation 1. What is equation 1? AR raised to power 2 equals to 24. So, because it is geometric progression. Now, division. This cancel this. R raised to power 5 divided by R raised to power 2. What would give us? Give us R raised to power 3. Right, so R raised to power 5 divided by R raised to power 2 will give us R raised to power 3. And then 192 divided by 24. 192 divided by 24 will give us 8. Okay, so we have R raised to power 3 equals to 8. All right, so now 8. We have R raised to power 3 equals to 8. What do? We find the cube root. Right, so we find the cube root of this. We also find the cube root of this. So you find the cube root of both sides. The cube cancel the cube root. R equals to what's cube root of 8? It means if you multiply 2 in 3 places, give us 8. So the cube root of 8 is 2. And our ratio is 2. The question says you find the common ratio. And the common ratio, which is R, is 2. Right, so this is another example, making it number 4. All right, so let's look at another example. If we have any question, we can ask. All right, so let's look at another example. Let's look at another example. So I still have enough questions, so we can treat as many as we can. All right, so now we have treated two questions on we have treated two questions on AP, and we have also treated two on GP. Okay, so now what do we need to do now is we want to look at another examples on pattern sequence, something like the Fibonacci that we discussed the other time, or we call it a mixed and logical pattern sequence. So now let's look at this. Number 5. What is the next sequence here? What is the next number? What is the next number in the sequence 1, 4, 9, 16, 25? Okay, so what is the next number in this sequence? All right, so as I've said before, that this type of sequence, you can't find the common difference, you can't find the common ratio, because if you try to find the common difference, it won't work. 4 minus 1 will give us 3. 9 minus 4 will give us 5. You can see that the difference is not common. And if you try the common ratio to 4 divided by 1 will give us 4. 9 divided by 4 will give us about 2 point something. So that will work as well. All right. So now this is not our regular arithmetic sequence, and is not our regular geometric sequence. Right. So this is a logical pattern sequence. So now you have to think critically for you to know what the next sequence will be. And then I'm sure that some of us, we are looking at it, we can even tell what the sequence will be. Right. So now, how do we get 1, 4, 9? That should be the question. 1 times 1 will give us 1, right? 2 times 2 will give us 4. You can see that it follows that pattern. 1 times 1 will give us 1, which is this. 2 times 2 will give us 4, which is the next one. 3 times 3 will give us 9. That follows. 4 times 4 will give us 16, the next one. And then 5 times 5 give us 25. Okay, these are perfect square numbers. These numbers are perfect square numbers. They are consecutive perfect square numbers. And I'm sure that you know what the next one will be. The next one will be 6 times 6, which is what? Which is 36. So it means the next sequence is going to be what? It's going to be 36. The next sequence then will be 36. That will be the next sequence. All right, so this is how to treat questions like this. All right, so let's look at another questions on logical pattern sequence or Fibonacci. Let's look at another one. Let's look at another one. Okay, so this one says what? Okay, let's look at this one. A sequence is defined by a difference given by sequence divided by this, Tn equals to 3n plus 1. And then the question is now, what is the 12th term? What is the 12th term? All right, common difference is we don't know what the, but the only thing we know is that we have a pattern, we have a sequence which is defined by this, and you have to find the 12th term. Now, I told you the nth term, if you have the nth term, and you have to find means is that our n equals to 12. So it means from here, anywhere we see n, we are going to write 12. Right. So anywhere we see n, we're going to write 12 because the n is represented by what? By 12 here. So our Tn equals to 3n plus 1. So the 12th term equals to 3. The n is 12 plus 1. So 3 times 12 will give us 36 plus 1, and that is 37. So it means that the 12th term of this sequence is what is 37, which is defined by this pattern. Now let's look at another example on AP. Another example on AP. Okay, number 7. This one says which term, which term of the sequence, which term of the sequence 3, 7, 11, 15 is equal to 99. Okay, which term of the sequence 3, 7, 11, 15 is equal to 99? Okay, so what it is saying is that you know this 3 to be the first term, you know this 7 to be the second term, you know this 11 to be the third term, and 15 to be the fourth term. Now, if you continue like that, you get to a point where you have 99 as the next term. Right. So the question is not saying which of the sequence, like what number, what term will give you 99? Is it the fifth term? Is it the seventh term? So now, this 99 represents the last time. And then, I said that Tn equals to a plus n minus 1. So the last term of a sequence also represent the last term of a sequence. So it means the Tn here is also the last term and it's already been given to be 99. All right, so now it means our Tn is 99, which is the last term. Our A is 3. From here, our A is 3. And our common difference between the second and the first, the third and the second, like that. So what's the common difference? 7 minus 3 will give us 4. 11 minus 7 will give us 4. So it means the common difference is 4. And then our n, we don't know. We don't know what the n is. Because we have to find the term, that is the nth term, that will give us 99 as part of this sequence. All right, so what we are actually looking for is our n. So our Tn is given already. The last term is given. Our Tn is given. It's given to be what? 99, because that's the last term. All right, so we're going to use the formula Tn equals to, what is the A? A is 3. What is our n? We don't know what the n is. So n minus 1. The common difference is 4. All right, so our Tn is 99. So we have 99 equals to 3 plus, we open this bracket here, 4 times n will give us 4n. 4 times 1 will give us 4. All right, so let's collect like terms. We have 3 minus 4. So we have 3 minus 4 plus this 4n. Right, so we have 99 equals to 3 minus 4 will give us minus 1 plus 4n. We bring this here. So we have 99. By the time you add this, it becomes plus 1 equals to 4n. 99 plus 1 will give us, we have 4n equals to 100. We divide both sides by 4. So if you divide this by 4, you divide this by 4, our n equals to, how many 4 can we see in 100? 25. So that means that the 25th term of this sequence, of this arithmetic sequence, will give us 99. Right? So if the first term is 3, the second term is 7, the third term is 11, the fourth term is 15, Then the 25th term will be 99. So that is what the question is asking us to do. All right, so let's try another one from GP. That is example 8. Let's try another one. All right, this one says that the sum of the first four terms of a GP is 80, and if the first term is 5, you have to find the common ratio. Find the common ratio. Okay, so this is the question. The sum of the first four terms of a GP is 80. If the first term is 5, find the common ratio. All right, so now let's write what we have. So this is GP, and you know in GP we have two formula, and the sum. We are dealing with the sum of the GP. The sum of the first four terms of the GP is already 80. So for GP, and what's the common ratio? We are finding looking for the common ratio. So our Sn equals to A R raised by n minus 1 R minus 1. Okay, so this is what we have. The sum is given to be 80. So let's have what we have. The sum is 80. Then our n is 4. Find the sum of the first four terms. So our n is 4. Our first term, which is A, is 5. What we are looking for is the common ratio. We are looking for the common ratio. So the sum of the first four terms is 80. So we are going to write 80 here equals to our A first term is 5. We write 5 here. We don't know what the R is. Our n is given to be 4. So we have 4 minus 1 over, we don't know what the R is, minus 1. Okay, so we open this bracket. We have 80 equals to, multiply this, 5 R raised by 4 minus 5 times minus 1 over R minus 1. Then what do we do here? We cross multiply. This multiply this, and this multiply this. So we have 80 R minus 1 equals to 5 R raised by 4 minus 5. Okay, we can factorize this. Let's write this. 5 open bracket R raised by 4 minus 1. So 5 can go in 80. You can say 5 here 1. 5 in 80 is 16. So we have 16 R minus 1 equals to R raised by 4 minus 1. Okay, so from there, we can open this bracket here, or we can as well factorize this. Or let's open the bracket. We have 16 times R, give us 16R minus this times this, 16 equals to R raised by 4 minus 1. Then we can collect right times, this and this. So we have R raised by 4, okay, minus 1. If you bring this, it becomes plus 16. Then equals to 16R here. So we have R raised by 4. This will give us minus 1 plus 15 will give us plus 15 equals to 16R. All right, so we bring this one here. We have R raised by 4 minus 16R plus 15 equals 0. So we have to solve this this is a polynomial. And then uh, let's test for small value of r. Okay, so now if you put r equals to 2, let's see if what we're going to get here will be 0. Right, so if r is 2, for example, if r is 2, we have 2 raised to power 4, and that's give us 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we have 16, and this one is SLR is 2. Okay, 16 times 2 is 32. So you're having 16 minus 32 plus 15. You give us minus 16 plus no to give us 0. Okay. Right, so 2 didn't work. Let's try 1. If you use 1, that will be 1 minus 16 plus 15. Yes, that will work. So r equals to 1. If r equals to 1, we test for small values of r. We add r here, which is 1. So 1 raised to power 4 minus 16, r is 1, plus 15 equals 0. Right, so 1 raised to power 4 will give us 1. 16 times 1 will give us 16 plus 15. So minus 1 minus 16 will give us minus 15 plus 15. So minus 15 plus 15 will give us 0. So 0 equals to 0. That means that our r is equals to 1. And that's what the question asks to find. Find the common ratio. Our r equals to 1. Okay. So, all right. So that is another example of geometric sequence. All right. So let's look at another one. Let's look at another one. Example 9. Example 9. Let's look at another one. All right. So um, find the next term. Find the next term or the next number. We have 2, 6, 12, 20, 30. Right, so I want us to find the next number. I want us to try this. Let's find the next number. This is a logical pattern sequence. And I'm sure we can get a common difference and we can get a common ratio. All right, so it's a pattern that we need to figure out what the next term is. So who is telling us what the next term is? What will be the next term? The next number. Okay, somebody said 50. So how do we get 50? Let's see if this person is correct. What pattern do we have? We have, okay, how do we get this 6? How do we get this 6? 2 times 3 will give us 6. Okay, that won't work. What's the difference between this and this? Is 4. Difference between this and this is 6. Difference between this and this is 8. Difference between this and this is 10. You can see they have, the difference is multiple of 2. Right, so difference between this and this is 4, is 6, is 8, is 10. So we expect difference between this and this to be 12. Right, so difference between this and this will be 12. So our next term should be 30 plus 12, which is 42. Our next term is 42. Right, so our next term is 42. So the person said 50. She's actually close, but the answer is 42. Okay, so uh, let's check another one. That's example 10. And then we might stop at that example number 10. Number 10. If the sum of the first 10 terms of a GP, of an AP, let's make it an AP is 145, and the common difference is 3. Find the first term. Find the first term. All right, so this is an AP, and then the first thing we do is write out what we have. It's very important. Now we are dealing with the sum of AP. So if the sum of the first 10 times of an AP is 145, so sum of an AP, this is the formula we use, plus n minus 1 d. All right, so let's write out what we have. The sum of the first 10 terms given to be 145. So it means this is 145. That means our n is what? Is 10, because first 10 terms, our n is 10. What else is given? We are given the common difference. Our d is 3. We are looking for a. We have to find the first term, which is a. All right, so is we are looking for the sum of the first 10 terms equals to, what is our n? Our n is 10, so we have 10 over 2. 2a, we don't know what the a is, we'll repeat that. Our n is 10, that will be 10 minus 1. The common difference is given to be 3. That will be 3. Right, so the sum of the first 10 terms is given to be 145. You're going to write 145 here. Here, 2 here 1, 2 here is 5. So we have 2a plus this minus this will give us 9. So we have 9 times 3 plus 9 times 3 is 27. So we can divide 145 by this 5. All right, you can say 5 here 1. What is 5 in 145? 5 in 14 is 2. That is 29. Equals to, we have 2a plus 27. So what we do, we collect like times. We bring this here. So it means 2a equals to 29 minus 27. And that means that our 2a is equals to 29 minus 27 gives us 2. So what is a? A equals to 2 divided by 2. Our a is what? Is 1. It means the first term of that sequence is 1. It means the first term of that sequence is 1, while the common difference is 3. So I think we have treated 10 questions on sequence and series, and this question should be able to cover the whole concepts in sequence and series. Okay, so all right, so now what I want us to do is I want to give us a question, and I want us to solve it and drop our answers in the comment section. So I want to give us a question to go and try and drop our answers in the comment section. All right, so let's write it. Let's try this. Let's try this. If the second term of a GP is 6 and the sixth term, okay, let's make it the fifth term, is 162. Find the first term and the common ratio. Right, so if the second term of the GP is 6 and the fifth term is 162, find the first term, that is the first term, which is A, and find the common ratio, which is R. So I want us to do it and drop the answer in the comment section. So this, don't forget, this is GP, and then we're having two statements. That means you're going to generate uh, two equations and solve it simultaneously. Algorithm. So, all right. So thanks for joining today's live, and don't forget to like, share, and also comment. I want your answers in the comment section. And if you have not subscribed, please do subscribe. So I will see us in our next class. All right. Bye.